Okay, well, I'll point out the fact that my name is not on the author list up here on the presentation. So what it turns out to be is Douglas Cortez had another conference this week, and Paola Bandini has a major conference next week that she's preparing for. So I got nominated to give their talk for them. My specialty is concrete, so geotech talk might be a bit of a stretch. Sometimes I might be knowledgeable about something, and sometimes I might just be mildly opinionated, so we'll try to keep it moving. The project is mechanical characterization of unbound aggregates. We'll go through the general format of the project, talk about background and motivation for the project, the objectives of the project, trying to mesh a new technology for mechanical characterization of aggregates into NMDOT's practices, and then look at the technologies that have been studied within this project and finally come up with some conclusions. The project is small. It's quite a bit. Funding on this project was only $26,000. It's mostly an assessment of possible technologies that could be used moving forward. It's not really the development of any individual technologies itself. To start off with background and motivation, in general, quality control and assurance testing for unbound aggregates is basically looking at percent compaction. And the standard test for this is interpreted as simply pass-fail. And it's all based on some pre-established target density that was determined in the lab. And the common test is the nuclear gauge density test, and it is very prevalent. So back in 2014, they did a survey of different states, and all of the states that responded say that they use this nuclear gauge density test and either use it by itself or in combination with another test. As motivation to try to improve this, Dr. Cortez has identified that, density isn't really what we want in terms of design or simulation of these materials. So something that would actually quantify strength and stiffness would be more useful than just a density measurement. He also points out that the nuclear density gauge is well, it's nuclear, which comes with some stress for some people, certainly some safety concerns, and some costs associated with handling and storage of the instrument. But my takeaway on motivation is just that he sees room for improvement. Instead of measuring density, try to quantify strength and stiffness, and if we can get away from a nuclear test, so much the better. The objective of the project really needs to be broken down into long-term objectives for where he sees this project fitting within a grander scheme, and then the specific objectives of this project. As the overall goal, what he wants to do is come up with a fully automated test device that's capable of testing, processing, logging the properties of the soils, in this case unbound aggregates and engineered fills. And when he says automated, I suspect that in the back of his mind what he's thinking is completely automated, perhaps robotic testing at some point. This project, being a small piece of funding to get started with, had specific objectives. The first one was to just look at what available tests are out there that might be able to compete with the nuclear gauge density test, rank them according to end user priorities, and that kind of implies that we know something about what the end user's priorities are, so he's put together a panel of NMDOT personnel to get their input on what they would prioritize in terms of things that they want from a test. Identify the tests that might be improved through automation, and then finally at the end of this project create a blueprint for how to automate that test. To assess NMDOT's priorities, he put together a group and surveyed them to find out what they thought was most important. The things that they identified was first that the test be accurate and repeatable, and it must really provide density measurements. They don't want to go away from density, even if you do give them mechanical properties. All of their specs are written in terms of density, and they want that to be a part of any new test as well. Certainly testing time should be quick. It's nice if the instrument is portable. They would like it to be low maintenance, low calibration costs, low training requirements so that it's inexpensive to operate. And the last one on the list is, yeah, mechanical parameters would be helpful. So strength and stiffness would be good, but it's not so high on their list. They've also identified some other things that would be useful. If it's easy to interpret, simply a pass-fail test, they like that. If it provides density in standard units that are familiar to them, say pounds per cubic foot, that would be a benefit. Other, I guess, more far-reaching things, if they could get to it, would be, if there was a failure, a test that was identifying that compaction was inadequate, is there some way to identify this to the inspector and contractor easily? Is it adaptable to a wide range of materials? And self-contained, I guess, would also be something that might make it more competitive. So based on those priorities, Drs. Cortez and Bandini set out to look at available technologies. The things that they identified as having the potential to perhaps be incorporated into a new instrument included the Clegg Hammer, the GeoGauge, the lightweight deflectometer, and the dynamic cone penetrometer. And they assessed each one of these, tried to essentially compare it to the nuclear gauge density test. And in terms of for the Clegg Hammer, found that it wasn't as accurate or repeatable as the nuclear gauge density test, with a coefficient of variation going as high as 20% in some cases. It was comparable in terms of testing time and portability, not nearly as robust, I guess, as the nuclear gauge density test, but it did have some benefits. It didn't require as much training, did provide some information about strength and stiffness, and it would be easier to automate than the nuclear gauge density test. The next one that they looked at was the GeoGauge. Again, not as repeatable or accurate as the nuclear gauge density test, coefficient of variation getting as high as 45% now. Comparable testing time, portability is about the same, not quite as robust, but again, minimal training, gives you something about strength and stiffness, and easier to automate. For the lightweight deflectometer, at this point, maybe not even as good as the first two. Coefficient of variation going as high as 77%. Testing time, even slower than the nuclear gauge density test. Not nearly as portable, not as robust. Easier to automate, which, if you don't have the other things, maybe that's not so helpful. And then the last one was the dynamic cone penetrometer. Coefficient of variation still can get high, 68%. Only real benefit here was minimal training. It didn't really show the potential for automation, so it's not worth looking at in too much detail, I don't think. So based on those reviews, they've had to assess what they can actually do with these technologies to try to come up with some improvement on the nuclear gauge density test. The things that they've come to realize, I think, over the course of this project was that NMDOT really wants density measurements. So the nuclear gauge density test is something that they're really not that disappointed with. Even though there might be room for improvement, it's perhaps difficult to get behind it. They like well-defined or familiar parameters. So instruments that come up with something other than density in well-known units, or stiffness or strength in well-known units, they're not terribly fond of. And in terms of the tests that were reviewed, there were some large coefficients of variation. And there wasn't really a standout test method. There was things that had some benefits over the nuclear gauge density test, but not all. So at this point, they don't see a good chance of replacing the nuclear gauge density test in New Mexico, but that doesn't mean that there isn't room for improvement on it. They'll probably continue to work on this over the coming years. They still would like to come up with a single device that actually will give more information, say density and stiffness and strength. And the last part of this project, the implementation phase, will focus on developing a blueprint for combining multiple technologies into a single device.